Alright, in this section here we're going to be talking about rational expressions with integer exponents, and we're just going to be simplifying. So let's remember here what a rational number is first off. So a half is a rational number, 3/4 is a rational number, 2 is not a rational number, that is an integer. This is with integer exponents. So if I were to say x squared over y to the third, okay, this is a rational expression. We have a rational number here. And so x might be equal to 5 and y might be equal to 2, and we would plug that in and we'd have a rational number. Alright, we're going to actually start off with some stuff that's not rational numbers first off, so we can kind of do a little refresher here on adding exponents, subtracting exponents. Let's say, for example, I had 2 squared times 2 to the third power. So if we want to simplify this, we would say this is 2 because we have the same base, and you would add your exponents, and of course this becomes 2 to the fifth, which I believe is 32. But anyway, so we add exponents, okay, as long as our bases are the same. So if I were to have 2 to the fifth times 2 to the negative 2, right, the bases are the same, you add exponents. This is 2, 5 minus 2 is equal to 2 to the third, which ends up being 2 times 2 is 4 times 2 is 8. Right? 8. Okay, now for an actual, maybe a rational expression here. 5 raised to the fourth power over 5 raised to the second power. Now I can take this and move this denominator up to the numerator. And when we do that, we change the sign of this integer here. It's a positive 2. When we take it into the numerator, it becomes a negative 2. And of course now, because our bases are the same, this is 4 minus 2, which can reduce down to 4 minus 2 is squared, and of course that's 25. So we have 5 4's in the top. We have 5 4's. We have 4 5's in the numerator and 2 5's in the denominator, and we just canceled 2 of them out of the denominator and 2 out of the numerator, and you were just left with 2. Alright, that makes sense, hopefully. Okay, something a little bit more complicated. What about negative? Well, I don't know if this is more complicated, but we're going to throw a negative in. Over negative 7 fifths. Now you notice we have 4 in the top, 5 in the bottom, so we can cancel 4 of those out in the top and 4 out in the bottom, and we would just be left with one of them in the denominator. Of course, you can always take this negative and bring it out front. Now remember, we can do this the old-fashioned way, taking this up into the numerator, but that becomes a negative, adding exponents, and so you have 4 minus 5, which ends up with negative 7 to the negative 1, but now we want to take this back down into the denominator, right, because it's a negative, bring it down, but we don't write a 1 here, right? But then we always want to bring this negative out front, okay? Alright, another way of looking at that. Okay, let's see. Let's do one more of those. Negative 2 squared over negative 2 to the sixth. Now there's 2 in the top, 6 in the bottom, so we're going to knock this out, or you know what, I'll just write it like this. And so we're going to take the denominator and bring it up. Because it's a positive 6, we take it into the numerator. And this becomes negative 2 to the negative 6. And then of course we can say negative 2, we can add our exponents. And this becomes negative 2 to the negative 4. Of course, then again, we don't want to write this with negative exponents. We want to write everything with positive exponents. So we're going to take that down into the denominator. And of course, this is negative 2 raised to the 4th power. And that's going to be, let's see, 2 times 2 is 4. So that should give us 16. Right. So 1/16, that's what our original is equal to. Okay, if I have 4 to the negative 1, and it's all raised to the negative 2, what we do here is we're going to multiply our exponents. So this becomes 4 to the negative 1 times negative 2, and of course this can be rewritten. Negative 1 times negative 2 is just 2, and this becomes 16. So this 4 to the negative 1, remember, is 1 to the 4th as a rational number, and it's all raised to the negative 2. So this is just another way of seeing this. What you can do here is you can flip this 4 over 1, and now instead of writing negative 2, we write a positive 2 here. Okay, another way of looking at this. This is, you can distribute this 2. This is 4 squared, and of course 1 squared. And of course this becomes 16. Now I could have wrote this 4 over 1 as just 4, right? 4 squared, which is 16. Alright. Alright, what happens if I had 5 to the 0, and that was all raised to the negative 4? Well, 5 to the 0 is 1, but let's just try it this way. 5 raised to the 0, right, you multiply exponents, but of course 0 times a number is just 0, and a number raised to the 0 is just going to always be 1. All right. If I had 2 to the negative 3 plus 4 to the negative 1, and we want to get this into a single fraction, right, which is going to end up being a proper fraction, you would write this as 1 over 2 to the 3rd plus 1 over 4. And this becomes, let's see, 2 times 2 is 4 times 2 is 8, so this becomes 1/8 plus 1/4. Now we got to get a common denominator. I'm going to multiply 2 over 2 here, and this becomes 1/8 plus 2 over 8. Now we have a common denominator, so we end up with 3/8 is our answer after simplifying all of this. Alright, let's see if you can get this one here. This is 3 to going to be to the negative 2 minus 3 to the negative 1, and it's all raised to the negative 2. So I can rewrite this as 1 over 3 squared minus 1 over 3. Now we're just going to focus on what's in parentheses here. I need to get a common denominator. This is 1/9 minus 1/3. So we're going to multiply a 3 over 3 here so we get a common denominator. So we end up with 1/9 now minus 3/9, which becomes 1 minus 3 over 9, which is negative 2/9. Okay, so now that we have negative 2/9, what we're going to do is go back up. Remember, everything is raised to the negative 2 power. So we would say negative 2/9 raised to the negative 2. Well, we can take this negative 2 here now and bring it up to each one of these. That's a 9 right there. Or the shortcut way of doing this is just to flip this thing. And so you could say negative 9 over 2. Okay, that's just a whole lot faster. Raised to the 2 power. And of course now we have negative 9 to the second power and 2 to the second power. Now you notice I took the negative and just brought it into the numerator up here, okay, and put parentheses around it because of the negative. Notice I didn't put parentheses around the 2 in the bottom. That's fine. But negative 2 squared is going to be 9 times 9, or negative 9 squared is 81, and 2 squared is 4. What happens if we had 9 over 8 and it was all raised to the 0 power? Well, remember, everything raised to the 0 power is going to be 1. So there you go. That was a little review there, a little refresher. How about if I had 5 over 8 and it's raised to the negative 1? Well, remember that you can flip this fraction, so you have 8 over 5. And we flip the fraction because we have a negative here, so we can write a positive now. But this is just 8 over 5 raised to the first power, which is just 8 over 5. Alright, let's look at, I don't know, I think let's start working some stuff with some variables in it. How about I had 7x to the 8th times y squared, so we're going to jump right on into the water here, and it's not too deep, I promise. X to the 6th and y. Okay, well, we have an x to the 8th and an x to the 6th. Now I'm going to rewrite this as 7. I'll just rewrite this 7 over 2 here and get it out of the way. We have x to the 8th times x to the negative 6. Now bringing this up into the numerator, change the sign, times y squared times y to the negative 1. I'm bringing this up into the numerator also. Now what do we do here? We add our exponents. We look at our like terms here. We got two bases that are the same, so this becomes x 8 to the minus 6 times y 2 to the minus 1. And of course we have this 7/2 out front. So 7 over 2 times x. So this becomes 2, and y 2 minus 1 is just 1. So there you go. It's been simplified all the way down. 7/2 x squared times y. Alright, let's look at another one here. So let's say we had 15 x to the 11th and y to the 7th, and that's all over 3 x squared y squared. So I'm going to rewrite this. First off, 3 goes into 15 5 times, so let's just get that out of the way. Bring this x squared to the top, so that becomes x to the negative 2. Y to the 7th times, bring this y squared to the top, so it becomes y to the negative 2. Now we add our exponents. And so we have y to the 7th, then minus 2. So this becomes 5x to the 11 minus 2 is 9, and y to the 5th. So that is now be simplified completely down. All right. Let's say we had, not that, 3y to the 9th over 2x to the 10th, and all of this is going to be raised to the second power. So what we're going to do here is I'm going to take this 2 up here and do just like this. This is 3 squared times y. Now you multiply exponents, so this would be 9 times 2, which is 18, over, now we have to also do it to the denominator, 2 squared times x, and 2 times 10 is 20. And so this just becomes 3 times 3 is 9, y to the 18th over 4x to the 20th, and there's not any more than we can do there. So that's it, completely simplified down. Three x to the 4th over y, and it's all raised to the 3rd. So try pausing the video and seeing what you get as the final answer while I work this out. 3 to the 3rd times x 12th, that'd be 4 times 3 is 12, over y to the 3rd, and so this time we get 27 x to the 12th over y to the 3rd. So that will be your final answer. Let's see here. Oh, man. Two x to the 4th over 5 y to the negative 2, and this is all raised to the 3rd. So this becomes 2 to the 3rd times x, 3 times 4 is 12, over 5 to the 3rd, and negative 2 times 3 is negative 6. All right. And of course we can rewrite this. This is 2 to the 3rd, so that's going to be 2 times 2 is 4 times 2 is 8, x to the 12th. This is 5 to the 3rd, which is 125. Now I'm going to take this y and bring it into the numerator, because we want to write our answer with positive exponents. That looks kind of sloppy. Let's rewrite this. 8 over 125 times x to the 12th times y to the 6th. How's that? Alright, so let's get a little bit more complicated here. Oh man, I always forget something. I'm not going to go into what it is I forget, but there's something I got to clear out before I do something on some software I'm using here. I always forget it. 2x to the third, and it's all raised to the negative third. Okay, so we're going to take this negative 3. Actually, okay, there was a shortcut. If you've been following my work on some previous problems, you know that if we have a negative up here, we can flip whatever's inside, and we're going to do that. Right, instead of going through all the algebra to get there, let's just take the shortcut. Now I can write this with a positive exponent. Okay, now what we're going to do is take 2 raised to the third. It's x, you multiply exponents, so this becomes x to the ninth over 3 raised to the third. And this is 2 times 3, which is 6. And of course, the only thing we can do here now is just go ahead and take 2 raised to the third, which is going to end up being 8 x to the ninth over 3 to the third is 27, and y to the sixth. Okay? Right. Okay, this will be a fun one here. We have negative 3 x to the fourth, y to the seventh, and that's going to all be raised to the third power, and then over 2 times x to the negative 4 times y to the third, and it's all raised to the negative 4. So this is raised to the negative 4, so that means we can take this up into the numerator. But I'm going to go ahead and start simplifying some of this stuff. We have negative 3 raised to the third. So we multiply exponents. 4 times 3 is 12. Y to the 21st, right? 7 times 3 is 21. And bringing this stuff up into the numerator, this is going to be 2x to the negative 4 times y to the third, and it's all raised to the positive 4 because we brought this whole thing up here. Okay, negative 3 to the third is going to be negative 27, x to the 12th, y to the 21st times, and 2 raised to the fourth times x. Negative 4 times 4 is negative 16, and y to the 12th. 3 times 4 is 12. What a mess. Negative 27, x to the 12th. Let's look for some like terms. We have an x to the negative 17th, so let's pair them up. Now, I should have brought this 2 to the 4th out here, but I don't know. Let me just write it like this for right now. Times, we have a y to the 21st times y to the 12th. I can bring this over, so this becomes negative 27 times 2 to the 4th is 2 times 2 is 4, so that'd be 16 times x. So we have 12 minus 16, and that's going to give us negative 4. So my brain shut down. We have a 21 and a 12. Let's see. So this is y. So we add our exponents. That's 2, 3, 33. So we're almost done here finally. Should have put a parentheses around that. This is going to end up being, so this becomes negative 432. Now this is x to the negative 4, so I'm going to take that back down to the denominator. We want to write our answer with positive exponents. And so we do. X over 4. There we go. Alright, this is probably going to be our last one. That probably won't be the last time I do that. Let's see, 5x to the third over 2y to the fourth. So what you need to do is, once I write this, pause this video and try to figure this out yourself. We'll compare answers. Alright, so pause, pause, and pause. Okay, so this is, we can multiply exponents here. 5x to the third over 2y to the fourth. And that's exactly what we're going to do. Multiply exponents. Negative 2 times negative 1 is just 2. So now I can go ahead and write this as 5 squared times x. This is 3 times 2 is going to be 6 over 2 squared and y. And so 4 times 2 is 8. And so we end up with 25 over 4 and x to the 6th over y to the 8th. So that's what you should come up with. Okay, last one. X to the 8m over x to the 2m, and we want to simplify this down. So this is x to the 8m. Right, taking this into the numerator, this becomes x, making this a negative. So whatever this sign is out front, when you take it up to the, when you switch it, either numerator, denominator, the sign always changes. 2m, x 8m, and we add our exponents, negative 2m. And of course, these are the same, these are like terms, so this becomes x to the 6th m. So this all reduces down to x to the 6th m, and I think I'm going to be finished on rational expressions, just simplifying these. I'm sure I'll have more in the next section that are similar. Alright. Hey, we're here, go to math.com, click on the algebra, starting a new section here, integer exponents, and we'll start with 1.1. So this says simplify, and basically what this means is we're going to be getting it in the form of a number, the base raised to its exponent. Okay, so we have 7x to the 4th times 7x to the 6th times 7x to the 4th. I think I can remember that without having to write that down. 7x to the 6th times 7, did I say x? What am I thinking? To the 4th, got x in my mind there. Yeah. Okay, so this is the way this works. Exponents, we've got these two guys here, their base they're both the same, and if they're both the same, then we can just add their exponents. Right, so this just becomes 7 to the 10th, and that's as far as we're going with that. We're not going to find what is 7 to the 10th. So remember, when both of these numbers, so we might say x to the 3rd times x squared, And what do? We add their exponents. So this becomes x to the 5th. What if I wrote 3 to the 0th power? Well, believe it or not, right, so if we have an integer here raised to the 0, it's going to always be 1, right? It's going to always be 1. So no matter what this number is. So for example, if this was 1 to the 0, it is 1. 10 to the 0, it is still 1. Okay? Alright, so we kind of went over more than usual. So 7 to the 10th, let's go back. Let's click on the answer there. And we got 7 to the 10th power. Alright, so that takes care of that. We're over here at GoToMath.com. Come on by, practice your exponents. See you later. We're at GoToMath.com. Click on the algebra. Let's go down to integer exponents. And what do we got going on? Oh, and you know what? We got rational expressions. I haven't talked about what a rational expression is yet. So, but we'll get to that here in just a minute. All right. So we have 8 to the 13th times 8 to the negative 4, right? What are we going to do with that? 13 negative 4. Well, didn't mean to click on that. Hope that doesn't mess anything up. Let's see, 13 times 8 to the negative 4. Yeah. So remember what we said in the last problem. You just add their exponents as long as these are the same. Okay? And so you have 8 to the 13th minus 4. And that's going to give us what? 8 to the 9th. Right? Yeah, to the 9th. Okay. Now, let's talk about this here with this negative. What do we got going on here? If I wrote 1 over 8 to the 4, and if I were to take this up into the numerator, this can actually be rewritten as 8 to the negative 4. Alright, so the reason this section is called rational expressions is because, remember what a rational number is. That's a rational number, right? So we got these fractions, rational number, rational number, rational number. Okay, and even if we threw a negative in there, these are also rational numbers. Okay, what about this number? Is that a rational number? Now look at here, you can actually reduce this down to what? 2? 2 goes into 4 2 times. Alright, so this can be reduced down, actually can be reduced down to 2 over 1, right? But you'd end up just writing it like this. And what is that? That's a natural number. It's an integer. That's a rational number. It's written in some rational form here, but it can be simplified down. So let's think about that. Alright, so what are we doing here? Is that the answer? Is that what we're really looking for? What was that, 8 to the 9th power there? Okay. Alright, so we're over here at GoToMath.com. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to integer exponents and click on 2.1. Simplify and write with positive exponents. Simplify and write with positive exponents. So 5 and negative 11. If I can remember that. 5 and negative 11. Right, so I try to remember that, and I just pictured that in my mind, and there you go. So what do? We go ahead and we add their exponents. And so what are we going to get on this? Negative 6. But we want to write with positive exponents. So this becomes 1 over 8 to the 6th power. See, we just take that down into the denominator. Okay. So let's see what we got going on here. Simplify and write with positive exponents. 1 over 8 to the 6th. Of course, we would find out what 8 to the 6th is, but that's not the what's going on here with this exercise. We're just wanting to know, what do we do with these exponents, right? So that's what we're trying to get at here. Alright, so we're over here at gotomath.com talking about rational exponents, rational numbers, and dealing with exponents. Alright, see you in the next problem. We will have rational exponents here coming up, I think. Okay, we're at gotomath.com. Click on the algebra. Let's go down to integer exponents, rational expressions. So it says simplify and write with positive exponents. And this time, hold everything. Okay, so we've got the bases here, actual integers. Now they're unknowns. Unknowns. If I can get one to come up. Wow. So we have x to the 7th times x to the 19th. Simplify and write with positive exponents. Okay, 7 and negative 19. 7 and negative 19. All right, so if you've caught up with the last few problems, you should know how to do this, right? All right, so this becomes x to the 7 minus 19, and simplifying that, we'd have x to the, what do we got on that? So 7 minus 19 is 12, negative 12, right? Okay, I don't know, that was just a guess. So we got negative 12. And of course, we want to write with positive exponents, so this becomes 1 over x to the 12th power. 1 over x to the 12th power. Come over here. 1 over, and that's just, no, that's 2. I thought that was a 12 there. Okay, so 1 over x to the 12th power. Alright. So we're over here at gotomath.com. Come on by, see you in the next problem. Hey, we're over here at gotomath.com. Click on the algebra, go down to integer exponents, and we're looking at 3.1, it looks like. Simplify and write with positive exponents. Okay, so can we remember this? Negative x raised to the 4th, x cubed. X cubed. Alright. Now here's something we hadn't talked about. Okay, let's do something here. A little side work here. Let's say that I have negative 2 raised to the 2nd power. So what is this? This is negative 2 times negative 2, right? And we can always take these negatives. So this is kind of like saying negative 1 times negative 1, and then 2 times 2. But what is a negative times a negative? A negative times a negative is positive. So we just end up with a positive 4. Okay. So if this is an even number up here, and this, as you can see, the negative is inside the parentheses, what's going to end up happening to this negative? Well, it's going to end up canceling out. And actually, I can actually rewrite this as negative 1 raised to the 4th power times x raised to the 4th power. You see that? And so that'd be negative 1 times negative 1, which is positive 1, and then times a negative 1, which is negative 1, and then one more negative 1, so you have a negative 1 times a negative 1, it cancels out. You see that? So, okay. And therefore, what's going to happen here is we're just going to add these exponents. So I can actually break this up. Maybe you'll better see this. So that becomes 4x to the 4th times x to the 3rd. And so we know that this is all going to just be a positive 1, so we're not even going to write that. And then we add our exponents and we get x to the 7th. X to the 7th. So that's one way of looking at that. All right, x to the 7th. And there you go. Okay, so those kind of things can be tricky. You got to watch them. So you know if this were a negative number right here, or not a negative, but an odd number, not an even but an odd number, then we'd end up with a negative out front. Negative out front. Right. So we're here at gotomath.com, getting it figured out. See you in the next problem. Okay, we're at gotomath.com. Click on the algebra, let's go down to integer exponents. And I believe we're looking at 3.2. 3.2. Okay. So I know this section's over rational expressions, but we're getting the basics out of the way before we start really getting into what looks like it's in rational, what is in rational form. Okay, first. So it says simplify and write with positive exponents. So we have, looks like in case negatives here, so we got a raised to the fourth, raised to the seventh, raised to the fourth, and raised to the seventh. Alright, so what did we say in the previous problem? Remember, this can actually be written as raised to the fourth x to the fourth times, and this can be written as negative 1 raised to the seventh times x to the seventh. Now, what's going to happen here is, because this is an even number, this is just going to be a positive 1, but since this is an odd number here, this is going to end up being a negative 1. And we'll just do an example over here for an odd number. So as you see, this negative 1 times negative 1 is a positive 1, but a positive 1 times negative 1 is a negative 1. Okay, so that's going to be an odd number, right? All right. So we end up with negative 1 to the fourth times negative 1 raised to the seventh is going to end up being negative 1. So we're just going to write that right there. And then we have x to the fourth times x to the seventh, and so we end up with x to the, right, adding both of these together, and so we just end up with an, and you know, we don't want to drop the 1 here, so we end up with a negative x raised to the 11th power. Right, raised to the 11th power, negative x raised to the 11th power. So we're over here, go to math, get it figured out. See you in the next problem. We're at gotomath.com. Click on the algebra. Let's go down to integer exponents. And I believe we're doing 4.1 here. Oh, rational number. Simplify and write with positive exponents. We have x to the 10th over x to the 19th. X to the 10th over x to the 19th. I think I'm going to start writing a little bigger. Alright, so we want to simplify this thing down, and what we're going to do here is I'm going to take this guy and take it to the top, and when we do that, this is whatever, it's going to be the opposite of whatever this sign is. So for example, this is a positive 19, we take it to the top, it'll be a negative 19. Now if this were a negative number down here, when we take it to the top, it becomes a positive number, right? So it's just whatever the opposite is. Now what we're going to do is go ahead and add these exponents, and so we end up with x to the negative 9th. However, we don't want to write our final answer with a negative exponent. We're going to go ahead and bring that back down into the denominator and write it with positive exponents. So we end up with x 1 over x to the 9th power. Not too bad. 1 over x to the 9th power. So this stuff here you got to really get down. You know, this particular course I've got on here is probably the most important course if you're going to be an engineer or really anything in science and math, and engineering, I should say. Because once you get this subject down really well, everything else just follows in line. It's all pretty easy after that. So, most important course. What are we doing? We're over here at gotomath.com. Alright, and see you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to integer exponents. 4.2. Simplify and write with positive exponents. So we got 8 over 15. Alright, let's see if I can remember that. So once again, we got this negative here to deal with. So I'm going to rewrite this like such. And then we'll rewrite. Okay. Alright. Since this is an even number, right, that's just going to all cancel out to be 1. But since this is an odd number, this is going to end up being a negative 1. So we'll just rewrite this x to the 8th over negative x to the 15th. However, we don't ever leave negatives down in the denominator. That's a no-no. Okay, so we want to always bring those up. So let's do that. But I'm also going to have to bring this x to the 15th up here in the numerator. And I didn't mean to do that. So this is x to the 8th times x to the negative 15. And now what we'll do, what that was doing down there. Oh my gosh, I did that again. Okay, so we have x8 minus 15. Now what do we got? X raised to the negative 17. Negative x, what? Negative 7 is what I meant to say. But this needs to be written. We can't write with negative exponents, so this becomes negative 1 over x to the 7th power. See that? So all that reduced down to 1 over x to the 7th power. Can you imagine that? Yes, it did. So just throw the negative out there. I know that's not centered with the middle bar, but I did that because this thing was really close, and anyway, you get the idea. It was, I don't know, joined up. What happens is, for some reason, on my web page, stuff gets condensed, and that joins that bar right there. But anyway, forget it. All right. Okay, so we're over here, gotomath.com, getting it figured out. See you later. Bye. Alright, we're over here, gotomath.com. Click on the algebra. Let's go down to integer exponents. And I think we're looking at 5.1 here. Simplify and write with positive exponents. We have x to the negative 11th over x squared. X to the negative 11th over x squared. So this time we have a negative up here in the numerator exponent. So that's okay. Just do this. Go ahead, bring that up to the top. And that's going to be a negative 2. So remember, whatever the opposite, when we take this up into the numerator, it's the opposite of whatever the sign is here. And then we'll go through and add these guys together. So that becomes negative 11 minus 2. And that is x raised to the negative 12th power. So we got 1 over x to the 12th. 1 over x to the 12th. Remember, we want to rewrite with positive exponents. Rewrite with positive exponents. No. What did I say? Negative 11. Whoops. Oops. I'm sure somebody out there was going, that ain't right. What's you doing over there? That's negative 13, isn't it? I don't know. I was thinking that was a 10, I guess. Okay. We went back to the page and I seen the answer and I was like, uh-oh. Alright, so we had 1 over x to the 13th. Okay. So we're over here at gotomath.com. See you there. See you in the next problem. Tell your friends. Bye. Okay, we're over at gotomath.com looking at some algebra. Go down to integer exponents. And I believe we're looking at 5.2 here. So we have x raised to the negative 11 over x to the negative 5th. Alright, let's see if I can remember that. It's to the negative 11th over x to the negative 5. Yep. And of course, simplify and write with positive exponents. We need to make sure we read that. So I'm going to go ahead and take this up to the numerator. So we have x to the negative 11 times x to the positive 5. Remember, it's the opposite of the sign. We take it up to the numerator. And of course, that falls, when we take it down here, we change the sign also. So we have plus 5. So we have negative 11 plus 5, and that's going to be what? Negative 6. Right. But we want to rewrite with positive exponents, so we take that back down into the denominator, and what do we get? 1 over x to the 6th. So hopefully you're getting the hang of this stuff by now. Okay, you need to really get this stuff down. Math just kind of piles on top of each other. If you don't know what's going on down below, you're going to be in big trouble. Alright, what are we doing? We're over here, go to math.com, talking about rational expressions and integer exponents. See you in the next problem. Okay, we're going to go to math. I know you're probably tired of hearing that, but it's got to happen. What did we just get through doing? Ooh, I think it was that. So we're looking at 6.1 now, looks like. Simplify and write with positive exponents. We don't have to really worry about that right now, but we have x to the 6th raised to the 9th power. X to the 6th raised to the 9th power. So in this particular case, we're going to multiply the exponents. And that's what? X to the 5, 54. 6 times 9 is 54. Right. Now, what's going on here? Well, let's say I had x to the 3rd, and let's say that it was raised to the 2nd power. Now remember, we just multiplied the exponents, but what is this really saying? It's saying x to the 3rd. If we were to expand this out, times x to the 3rd. That means there's 2 of them, right? And so if I was to actually rewrite this, what do we got? X to the 3 plus 3, which is x to the 6th power. See that? And so let's do this again. How about if I had x to the 3rd? And you'll see the pattern. So this is x to the 3rd times x to the 3rd times x to the 3rd. And so what do we have? We have x to the 3rd, right? And then plus 3 again. We just added all those up, and so you end up with x to the, so there's 3 of these, and multiply them by 3 times 3, and we end up with to the 9th, right? But I think it's a whole lot easier just to go, hey, x to the 9th, right? Okay, so we kind of went a little bit above what we're supposed to be doing here, so we said that was x to the 54, right? Yep, there it is. Alright, so we're over here, go to math.com, getting it figured out. See you in the next problem. Okay, we're go to math.com, click on the algebra, let's go down to integer exponents. And you know what, I'll just click up here. Wow, it came right up. So we have x raised to the 7th, that's all raised to the negative 10. So the 7th, and that's all raised to the negative 10. So what do we do with these? We multiply them, remember, like in the last problem. So that becomes negative 70, but we want to write with positive exponents, so this becomes 1 over x to the 70, right? 70th power. Okay. Easy enough. Easy enough. 1 over x to the 70th. There you go. Alright, so what are we doing? We're over here, go to math.com, and I'm getting a text message, and it looks like I'm getting a message saying there's people on the website. Alright. Okay, so there you go. See you over there. See you in the next problem. Bye. We are here at go to math.com, click on the algebra, integer exponents. I believe we're looking at 7.1. Simplify and write with positive exponents. We have 1 over x cubed, and it's all raised to the ninth power. All raised to the ninth power. Okay, so we got something a little different here. Now, how can we break this down? Well, we can look at it this way. This is 1 raised to the ninth power over x cubed, and that's all raised to the ninth power. So that's one way of looking at it. Alright, it's the best way to look at it probably. So what is 1 raised to the ninth power? Well, that's just 1. I mean, what is that? That's 1 times 1 times 1 times 1 times 1 times 1. Did I say it 9 times? And then what do we do with these guys? We multiply them. So that becomes 1 over x raised to the 27th power. Easy enough. 1 over x to the 27th power. Alright, so we're over here at gotomath.com. See you next problem. We're at gotomath.com. Click on the algebra, go down to integer exponents. And I need to look at this. Okay. Did we just do this problem? Let's click on that, do something different. How about that? Simplify and write with positive exponents. We have 1 over x to the 7th raised to the negative 3. 1 over x to the 7th raised to the negative 3. Okay. So what do we got? We can break this up. Now there's a couple ways of looking at this problem, but we're just going to do it this way for right now. So what do? We're going to, well, we better just do this. Okay. Alright, so this is 1 over 1 raised to the negative 3. We could put a parentheses around that, I guess. What do we do with these exponents? I'm going to just have to rewrite this a couple times. We multiply exponents, so that becomes x to the negative 21. Now we want to write, whoa, let's get rid of that. We want to write our final answer, obviously, in positive exponents. Well, I don't know if that's obvious, but that's what it's asking us to do. We can go ahead and take this x to the 21 up here to the top, and then bring this 1 to the 3rd down here. But what is 1 raised to the 3rd? 1 raised to the 3. I mean, it's just 1 times 1 times 1, right? Which is 1. Okay. So we just get 1 down here in the denominator, and therefore we want to write our final answer. We don't want to write it over 1. Alright, we can simplify that down to x raised to the 21st power. Okay. And there it is. Okay, so we're over here at gotomath.com, getting it worked out. See you in the next problem. Okay, we're here at gotomath.com. Click on the algebra. Let's go down to integer exponents, and I think we're doing 8.1. Yes. Alright, so things are starting to get a little bit more complicated. Slightly. 10x to the 8th, y to the 5th, and it's all raised to the 6th power. Got it. We got it. Somebody's got it. X to the 8th over y to the 5th, and it's all raised to the 6th power. Okay. So we're going to distribute this guy. I guess that's what you want to call it. 10 to the 6th x, so we multiply, remember these exponents, 6 times 8 is 48, over, and then of course we have the y, 6 times 5, and that's 30. 30. Okay. And of course that's going to be some big number. I don't know what it is, and I'm sure it's actually multiplied out probably on here. Yep. Man, I don't know, should I have done that? That's kind of crazy. Alright, we had x to the 48 over y to the 30th. Let's make sure. Yep, that's it. That's it. Alright, we're over here at gotomath.com. Getting this stuff worked out. See you in the next problem. Okay, we're at GoToMath.com. Click on the algebra. Let's go down to integer exponents. And we're looking at 8.2, it looks like. Things are starting to get hairy now. So we have x to the 5th over 3y to the 10th, and all of that is raised to the negative 7. So hopefully you're getting the hang of it. Getting the hang. X to the 5th over 3y to the 10th, and that's all over negative 7. Okay. So what are we going to do? Well, we're going to multiply, and I don't know what that was. I don't have a clue. So this is 5 times negative 7, be negative 35. That's all over. So this is going to end up being 3 to the negative 7, and then y. So 10 times negative 7 is negative 70. Now we want to write this thing with positive exponents. So we got to do a little shuffling. We're going to shuffle our feet. Okay, so we're going to take this x to the negative 35 down into the denominator and take both of these up into the numerator. So this becomes 3 to the 7th, y to the 70th, so we're just exchanging places, and there you go. All right. Now this here 3 to the 7th, we're probably going to be multiplying that out and get some enormous number, some kind, I would imagine. Yeah. 2187, y to the 70th, x to the 35th. Right. I'm going to actually check that 3 to the 7th out there real quick. Okay, just making sure. Alright, so we're over here at GoToMath.com. See you in the next problem. Hey, we're here at GoToMath.com. Click on the algebra. Let's go down to integer exponents. We're looking at 9.1. Somebody is anyway. And we're going to simplify that and write with positive exponents. And I think I'm going to have to write that down. Negative 10 x to the 10th, y to the 15th over 11 x to the 15th, y to the 8th power. Okay. Huh. Alright, sorry about that. I kind of was watching something there. So we got negative 10. Zoned out. You're probably like, what's going on? Did you get abducted by an alien or what? That's possible. Y to the 15th over 11x to the 15th and y to the 8th. Okay. Alright, well this 10 and this 11, there's not much we can do with that. Those count. Alright, there's nothing, we can't do anything with that. But what we can do is we're going to take this x and this y up to the numerator. Yes, they're going to have a little meeting up here. And remember, we take it up to the numerator, sign changes. Y to the 15th times y to the negative 8. A hard time writing that stuff up. Now we're going to go ahead and keep this 11 down here. How's that? So we add the exponents. We have negative 10x. We've got 10 minus 15. That's negative 5. And then 15 minus 8 is 5, 6, 7. Right? And then of course we still have that 11 down here. So we're going to leave the y up here. It's got positive exponent. Yeah, better throw that 10 in right there. But we're going to take the x down into the denominator because it has a negative exponent, and we got to write this thing with positive exponents. So it looks like 10 times y to the 7th over 11 times x to the 5th, and of course we've got that negative out front. Alright, 10y to the 7th, negative 11x to the 5th. Yep. Alright, looks good. We're over here at gotomath.com getting it figured out. See you later. Hello, we're over here at gotomath.com. Oh man, I thought of a really cool video to make. What are we doing? Let's see, I think we just did 9.1. Let's click over here on that one. And that doesn't look anything like 9.1. Huh. Oh well, guess it doesn't matter. Whatever. Alright, let's let me write this down. So we have 3x to the 5th. This reminds me of a problem we did earlier. 6y to the 9th. Huh. Almost positive it's like a problem we did earlier. Alright, man, we'll just go with the flow. 3x to the 5th over 6y to the 9th, and it's all raised to something, to -3. So we go through and alright, so we got 3. This is going to be to the -3. X, remember we multiply our exponents, so that's -15. And so that's going to be, I see a situation going on here real quick. I should have noticed it before it got out of hand. Y to the -27th. Well, this can actually be reduced, right? Before we even do anything. 3 goes into 6 2 times, and we're going to do that. 2y to the 9th. Okay, we're going to work on this one. So we have x to the -15th. You know, we just end up with, I don't know, it's best just to do it this way. Alright. So we have 2 to the -3. And then we'll have y, so 9 times 3 is 27. Alright, so we want to write with positive exponents, and that means that we're going to be switching places here. So we're going to have 2 to the 3rd up in the numerator, y to the 27th. We'll simplify that down here shortly. And then x to the 15th. Right, just switch places so we all have positive exponents. So what is this? This is 2 to the 3rd. That's 2 times 2 is 4 times 2 is 8. Y to the 27th. And we've got this bar here, which is kind of a nuisance, and then x to the 15th, so we'll do that. Alright. Okay. Now, back to here. There's a quick way of looking at this. We have a negative here. You could just flip everything. 2y to the 9th, x to the 5th, and then this becomes +3. See that? So, and then we could just go from there, instead of having to go through this whole route here. Alright. This thing here, you know, we just end up writing, bringing this up into the numerator, and then adding, you'd end up with 3 to the 0. What? Oh, you can't do that because these are both bases are different. I don't know what I'm thinking there. Anyway. Okay, 8 y to the 27th over x to the 15th. We got that. Over x to the 15th. Alright. So we're over here, gotomath.com, getting it worked out. 2 more problems. We'll be done. See you later. Okay, we're over at gotomath.com. Click on the algebra. Let's go down to integer exponents. And we're looking at 10.1. 10.1. So let's write this down. We got 2x to the -7th over 6y to the -4, and that is all raised to the -1. Raised to the -1. All right. what are we doing now? That's what we're doing. So 2x to the negative 7 over 6y to the negative 4 right, it's all raised to negative 1. So the first thing we want to do here is let's simplify this down a little bit. Alright, and that is we're going to write this with x to the negative 7 over y to the negative 4, but 2 goes into 6 3 times. Okay, so that's going to do that. Now what we can do is go ahead, take the negative 7 times negative 1. What do we get? Well, we get a positive 7. That's cool. But we got 3, negative 1. And then y to the negative 4th, y to the negative 4, and the negative 4 times negative 1 is positive 4. So really the only thing we got left here is we can't keep this 3 raised to the negative 1 in the denominator. We'll go ahead and take that back up to the numerator. Take it up to the numerator. It wasn't ever there in the first place. Alright, so there you go. Okay, so hopefully you were able to keep up with that. 3x to the 7th over y to the 4th. 3x to the 7th over y to the 4th. There we go. Okay. Alright, one more and I'm done. See you in the next problem. Okay, we're going to go to math.com, about to run out of juice, which means I need to hurry. I can't have this thing plugged in while I'm recording because it makes this terrible background buzzing, humming noise. And so I'm just hoping that we can get this done before this computer shuts off. Okay, so there will be no playing around here. 3x to the negative 6th over 3y to the negative 8 and z squared, and this is all over something, negative 2. Okay, so we're going to have 3 to the negative 2, so negative 6 times negative 2 is negative 12 over 3. Oh, we could have just canceled that out. We'll do that here in a second. I didn't see that. And so we have negative 8, negative 2, so that becomes y to the 16th, and then 2 times negative 2, so that's negative 4. Now we want to write with positive exponents. We can go ahead and just cancel those guys out. So we're going to end up with z to the 4th in the numerator, and then x to the 12th in the denominator. Y, that's supposed to be a y. That thing has morphed into something strange. So we have z to the 4th over x to the 12th, y to the 16th. Alright, z to the 4th, whoa, wait a minute. Gosh darn it. What happened here? I got in a big hurry. Okay, that's a positive 12. Wow. That would be, okay. Sorry about that. God, that's what happens when you get in a hurry. So that's a positive 12, so that's going to be x to the 12th up here in the numerator. Alright. X to the 12th, z to the 4th. Is that another mistake I made? No, z to the 4th and y to the 16th. Alright, looks good. So that's going to be the end of this section. We're moving into the next section. See you over here, go to math.com. See you in the next problem. Bye.